Everyone, thank you so much for coming to the elevator talk. It's 10 in the fucking morning and I cannot believe we have anyone here. That's amazing. It's almost a full house. My name is Ege, it's spelled like that. That usually helps.
And my name is Bobby. It is also spelled like that.
And we're with the Physical Security Village. You might have seen us in Hall 2. If you haven't, you should definitely take a look. And today we're going to be talking to y'all about elevator hacking. So elevator hacking is using elevators in a way that they're not designed to be used to do things that you were not meant to do. We can put them in special modes of operation. We can mess with them in other ways, but the gist is that we want to use elevators in a way that they weren't designed to be used to do things that we weren't meant to do. So why would one want to do that? I mean, it's fun to play around with large industrial, or not industrial, but like large machinery, that's a given. But from a practical security perspective, sometimes we want to get from point A to point B, and there are barriers in our way that we can't easily bypass, that we can't get the credentials for, or are just straight up not designed to be opened by anyone. It might just be like a wall between the insecure area and the secure area. And what we can do in that case is we can do something that maybe the people designing the security have not thought of. We can yeet ourselves in the air 3 stories, walk across, and then come back down. So you're going to see a lot of safety disclaimers in this talk. Elevators are incredibly safe when you operate them the way they were designed to be operated. But when you start to mess with them, they might do things that in their heart they are trying to do to protect you, but end up hurting you really, really, really horribly. We're going to be talking about putting elevators in special modes of operation. One of these is emergency fire operation. I'm going to be talking about that later. And I'm going to also be talking about this specific danger when I get there, but you can get the elevator controller really mad at you, and you can break someone else's really expensive elevator in a way that requires a really expensive service call. You can electrocute yourself trying to mess around with wires, and we're going to be talking at a fairly surface level about hoistway access, and that's just, you know, like a 20-story hole that you can fall down, right? That's not great. Also, there are other dangers. So what's that to say is this is an introduction only. It's meant to serve as a this is what's available. If you are interested, you should learn more about it. But this talk does not mean that you should start playing around with elevators just right away. Yeah, so I don't like doing agendas that much, but apparently people find them helpful. So this is what we're going to be talking about. And also we're going to have some case studies at the end. And let's get started with some of the basics and some of the terminology that we're going to be using. So the floaty box that you stand in is called the elevator car. It has, it is suspended by either from the top by cables, that's called a traction elevator, or it's suspended from the bottom up using pressure in a hydraulic piston, that's called a hydraulic elevator. So these are how they move. Oh, and important is, for the traction elevator, there's a counterweight to kind of, counterweight the weight of the car, and that is one of the dangers that that we're going to be pointing out about hoistway access, which again you shouldn't do. So I'm sure this is the bit of the elevator that you've interacted with the most. It's the hall buttons on the hall panel in the hallway. Those are used to register what is called a hall call. It's the going up, going down kind of a call. And inside the car, the elevator car, there's the car panel, which has the car buttons on it, and that's used to register a car call. A lot of repeated words. Now, there are instances where we can't necessarily use the car buttons because they're locked out. The elevator controller is not letting us because we haven't presented a valid credential. And how can we avoid registering our car call, but also still making our way up to a restricted floor? This doesn't always work, but when it does, it's actually kind of neat. And to explain that, I want to explain something called homing. The elevator doesn't always just sit at the floor it was last left at. So for example, at hotels, if it's around check-in time, it might be programmed to go down to the lobby, even if it left someone at the 25th floor, because chances are the next person using the elevator is also going to be going up from the lobby. So we want that person to wait the least amount of time as possible so that it's a better user experience. So it will home at the lobby. And when it's checkout time, it might do something else. It might home at one of the higher floors, and it might wait there. So it's a quicker travel to the next user, and we can make use of that. If we want to access the upper floors and the elevator is not programmed with security in mind, we can just get inside the elevator, wait for it to home, go up to whatever floor, and we can, after it levels, we can just press the door open button, and sometimes it'll just let us out. But obviously that doesn't always work. So how can we take advantage of something more privileged than just, getting in the darn thing and waiting? We can put the elevator in special modes of operation. The first one we're going to be talking about is called independent service. So basically what independent service does is it takes the elevator out of the bunch of elevator. Basically, it takes the elevator out of the mode where it just responds to hall calls and car calls normally. It will take it out of the bank of elevators and put it into independent operation. And what's important here is that in independent service mode, it will basically only care about what the person who is currently inside the elevator wants. So if you press a button and push door close, it will take you up to whatever floor you want. And in a lot of cases, it will just ignore any floor lockouts. And this is almost always on purpose because independent service is used a lot by custodial staff, by movers and stuff like that, where you don't want to have to badge in and out every single time. So just having the key to put the elevator in independent service is treated as the authorization to go to whatever floor you want. Also, you can use an elevator independent service to just hide if someone's looking for you in an engagement and you don't want to be found, especially in a multi-bank elevator. You can just drive it to whatever floor you want, put it in independent service mode, push door close, doors will close, and it will just sit there. And if it's as I said, if it's a multi-bank elevator with like a bunch of different elevators, chances are no one will actually notice that, elevator 3 hasn't been responding all day. You just like you press the hall call button, and elevator shows up, you get in, and you go where you want to go. So yeah, that's that about independent service mode. It's a very useful mode of operation, and we're going to be talking a little bit about how we can enable those later on, but it's almost always a key switch. Next up is attendant service mode. This doesn't always come up, but it's a nice, it's an interesting throwback to when elevators used to have attendants that moved a giant rheostat one way or the other to make the elevator go up or down. And basically, the attendant service mode, the attendant steps into the elevator, flips a switch, and the elevator is again theirs. And they can choose to skip hall calls. They can choose to reverse direction at any point, and basically give VIP service to a VIP that they might be servicing. Now, why do we care about this? Because attendant service mode is is designed to allow, morning, because attendance service mode is designed to give special priority to VIPs, in a lot of cases, you don't actually have to present a credential. Sometimes, if the elevator is programmed with security in mind, this won't disable floor lockouts and you will still have to flip that switch or present your credential. But in some cases, if the attendant is there and they see that a VIP has arrived and they want to take them up to the penthouse, it's programmed with without the need for the VIP to fish their room key up and present it to the elevator, because that just gives a better customer service. The next mode of operation we're going to be talking about is actually a very powerful one. It's the most powerful operation mode, and it's inspection service mode. So basically, this is used when an elevator technician, not you, not me, an elevator technician needs to get into the hoistway or inspect the bottom or the top of the elevator car. You might have seen switches like this on the lobbies or whichever the designated landing is, where it says inspection up, down, or inspection on, off. That's what it's used to put the car in inspection mode. And because inspection mode is designed for someone to be physically inside the hoistway, it gives them the most amount of control, because it's extremely dangerous for the elevator to move in a way that the person inside the hoistway doesn't expect. Oh yeah, also Juanab, shout out to at Juanab on Twitter, my friend Karen. That's where that handle comes from. And that stands for Hoistway Enable. Next mode of operation that we're going to be talking about is fire service mode, or fire emergency operation mode, or fire operation mode. It goes by many different names. Basically, this is the mode of operation that an elevator goes into when it believes that there is a fire in the building. Why, you might ask? Is there a special mode of operation? Because fires are obviously extremely dangerous, and even more so if you're an elevator. Just imagine the elevator showing up to a floor that's currently on fire, opening the doors and waiting the minimum required amount of time with the doors open, specified by ADA, which is a great thing. It's just not so great when the floor is currently on fire. So to keep you safe, it will lock out. It will not allow you to use the elevators, and to get you out as soon as possible, it will reverse direction if needed, not collect any more hall calls, and it will go to the designated landing. It's usually floor 1, lobby, whatever. It's the one with the star next to the landing that you might have seen. And you might ask, how does it know that the floor is on fire? You'll see these all the time now in elevator lobbies. By code, there's always a smoke detector or a heat detector, and that's how it knows that the floor is currently on fire, or at least some part of the floor that is near the elevator, which is what it cares about. Also, interesting tidbit, you might ask, okay, cool, what does it do if level 1 or the designated landing is on fire? It goes to another floor, usually one above the alternate designated landing. That, what I'm talking about, is phase 1 operation. That was the default one. But then they realized elevators are actually, as long as the person inside the elevator expects the possibility that they're about to show up at a floor that's currently on fire, it's actually a very useful firefighting tool. Because if floor 27 is on fire, you don't want the firefighters to lug around all their equipment 27 stories up on the stairway. So if someone with the right credentials, i.e. a key switch, shows up, they can be put on what's called phase 2 fire operation. In this case, the elevator still ignores everything, but it operates in a way that is slightly similar to independent service mode. So it ignores everything, and it can take the person who's currently inside of it up to whatever floor they want. Which is obviously useful. But before we get into that, again, a safety disclaimer. Don't do this. Unless you have very specific permission and you have very specific training, you will get the elevator controller extremely mad at you if you do things out of sequence. And to reset emergency fire operation can sometimes take several different steps that may or may not involve accessing the actual physical elevator controller box, which you might not be able to do for the LVCC if you decide to mess around with the elevators here, right? So don't do that. And you can still demonstrate impact for your clients by saying, hi, I have this key that is for your, like I bought it from Amazon for $20, and I can mess around with your elevators, put them in emergency fire operation mode, and drive them wherever I want, without actually showing up and putting the elevator in emergency fire operation mode. Oh, and also, when I say training, I mean actual training. This talk doesn't count. So with that being said, why is this useful? So this is an excerpt from the standard that applies to the US and Canada. And inside the code, it says that when the elevator is in emergency fire operation mode, it has to ignore any sort of authentication, any sort of security programming, anything like that, because if the building's on fire, the firefighter doesn't necessarily care. Like, they care about putting the fire out, right? They don't necessarily care about, oh, but I have, sensitive documents on floor 25, which is like 2 below the floor that's currently on fire. No, like, they have to get there. They have to fight the fire. So any floor is accessible without credentials. And this is something that your clients might not necessarily know about, because they might be told correctly, hey, yeah, no, this elevator will not let anyone up to whatever floor without presenting valid credentials. But this is something that they should include in their security planning. So we talked about a lot of special modes of operation. How do we get these elevators in these special modes of operation? We use keys. These are almost always standardized. Here is a bunch of them that you can find through various different stores, online and offline. Some of them will ask you to prove that you are, an actual elevator technician. Some of them will not. You might see some names here that key names that you recognize. However, you can't always rely on the standard keys being used. If a building is more security conscious, and if they're not forced to by code, they might use actually good keys, or actually good key switches. So on your left-hand side, you can see 4 key switches. Who wants to tell me what type of key switch that looks like? It's a wafer key. It's a wafer lock. Is a wafer lock a very good lock? No, it is not. I can pick it with, the cap of a ballpoint pen. On your right-hand side, there is a different type of. There's a bunch of different type of key switches. Who can tell me what type of key switch that is? It's a medical cam lock. Yes. Is a medical cam lock a very good lock? It is a very good lock. If you're not lockpicking lawyer, I don't think you're picking that. So how can we get around this? If we assume you genuinely don't have the time to sit in the car and go at it for 20 minutes to pick the medical lock. Well, you can just avoid the key switch altogether. We can activate a key switch without actually turning the key inside of it by just shorting or pulling the wire on it, right? Key switches might feel like magical things that if you turn the key, the elevator controller somehow knows that you turned the key. No, it's pretty simple. It's just 2 wires go to a switch. If they're touching, that sends a 1 signal or a 0 signal or whatever. And if they're not, it sends the opposite signal. So what we can do is we can take the panel off, being careful not to short anything that we don't want to short. And this is what the back of one of those key switches looks like. It's literally just 3 terminals. So if it is expecting, or if the mechanism is currently shorted, so if the key switch is on for a normally open switch, we can just pull one of the wires out, or if we want to do it non-destructively, which we should, we can just take our handy screwdriver, unscrew the contact, and take it out normally. Or if if the mechanism is currently open, so it's sending a 0 signal for a normally open switch, we can just take something conductive and bridge those two contacts, and the elevator controller will now think that that key switch has been turned. Also, another safety disclaimer, I know you're sick of these, but some of the especially old ones that work on straight relay logic will just send 120 volts mains voltage to these panels. So yeah, like this is a dead panel. We're just taking these photos, demonstrating it. Just be careful. Use an actually insulated tool. They're extremely uncommon. They just work at normal PLC voltages, but like, you might hit the jackpot, so to speak, with the one out of however many that actually does send mains voltage back there. Oh, and another one that sometimes comes up is when I press a button, it lights up, but then the elevator controller realizes I shouldn't have access, and it disables, it like unlights it up instead of staying lit up for how a car call would normally behave. Can I just push it in, hold it pressed in, and then it'll just stay lit up the whole time? Almost certainly no. We gotta ask this sometimes. Almost certainly no, but I have actually seen it, or well, Bobby has seen it happen in 2 engagements, I think you said?
2 engagements,
yeah, 2 engagements. This has actually worked. We have no idea how it worked. My presumption is that he was just like seeing what happens and then it worked. I don't know. So if you have nothing else you can try this, but it's probably not gonna work. Alrighty, and I'm gonna pass it off to Bobby for Hoistway access, which will start with a safety disclaimer again.
Alrighty, so we're gonna get into Hoistway access. So once again, another quick safety disclaimer. This is something that should be performed by trained professionals only. It is very dangerous, it can kill you. There are a plethora of things that are obviously dangerous in these pictures. There are also a ton of things that are not visible at all. So please don't do this unless you know what you're doing and have the training. So we're gonna start off with the anatomy of an elevator door. So there's a few different doors actually. There's the inner elevator door, which you can see on the left there. That is part of the elevator car itself. So that's the one when you're inside the elevator, door closes, you move up a floor, you do not see the wall moving in front of you. That's what that one does, keeps you safe. And the outer door. So that's the one when you're in the hall, you're waiting for the elevator to come. This is also called the hoistway door sometimes, and it keeps people from falling into the hoistway when the elevator is not there. We also have the escutcheon hole or escutcheon tube. So some of you may know what it is. Some of you may have wondered in the past, what the heck is that tiny little hole in the top corner of a door? So we're gonna cover what that does. So here, we have an escutcheon hole. Here, escutcheon hole, escutcheon hole. You're gonna be amazed at this next one. Escutcheon hole, and ooh, look at that, even more. So as you can see, generally, it's a tiny thing. It's going to be at the top of one of the doors. It can be a few different shapes, but the function is essentially the same. So how do we enter the hoistway? The big question. So keys do exist. They are interacting with the escutcheon holes. We're not going to discuss precisely what keys. They are out there for professionals who are trained to use them. They allow you to open up the doors. Bypasses also do exist for this purpose. Again, we're not going to cover those. If you are a professional who knows about elevators, it's pretty easy to figure out with the mechanics of things how you might bypass the escutcheon hole at all. Again, please don't do it unless you know what you're doing. So just to highlight it here, this is 3 of many deaths that have occurred over the years from people getting into hoistways without knowing what they're doing. It's a very dangerous place to be. Again, a list of different dangers, some but not all of them, within the hoistway. So let's say you are trained, you know what you're doing, you open the hoistway doors, You've already put your elevator car on the floor below you, meaning that the top of it is at a height where you can access it. And you're looking down at it, and this is what you see. So what's going on in here? What are all these things that we're looking at? So first off, we have this little box there. You can see that there's a red bell on it. You can see that there's something next to that. That's a light bulb. And what that little box is it is the car top control box. So this is how a trained technician or elevator professional would control the elevator's movement from within the hoistway. This has a light switch for the light. It usually has 120 volts for tools, and it has controls that let you move the elevator up and down within the shaft. Next up, we have this down below here. So this is the door mechanism. This is what allows the doors to open and close on the elevator car specifically. So you can see there's a motor there. It's belt driving a little gearbox with some mechanisms that open and close the doors. And this is also what opens the actual doors in the hallway. So the way that works is when the elevator comes to the right floor, the inner doors and the outer doors engage together, and so this mechanism on the elevator car itself is going to open both sets of doors simultaneously. Here you can see what's called the cable riser. So we have buttons on every single floor, and how do we get those signals up to or down to the elevator control room? Well, the answer is that you can see there's some conduit going out from below into this cable riser. This takes the cabling up and down the shaft. Here on the side, these are called the guide rails. So these do not have to do with actually raising and lowering the elevator itself with force. All that these are here to do is keep the elevator from rattling around inside of the shaft. They make sure that it stays on a trajectory up and down. And these are one potential pinch area. So as you can see where those little red triangles are on either side, if the elevator is going down and you happen to brush up against a rail, it's probably just going to, tug up on you a little bit. But if the elevator is going up and you were to have long clothing, hair, a finger, really anything go in there, it can be sucked in. And the elevator is not even going to think about that small amount of additional force of you being pulled into that. So one other thing, does anyone know what's missing here? Is there anything that you think should be present in an elevator shaft and is not? Cabling. Someone said cabling, and that's right. So this is a hydraulic elevator. Also, someone said spy, and that's another good answer. So this is a hydraulic elevator. What that means is that on the bottom, as you saw in the earlier part of the talk that Ege did, that means that it has a huge piston underneath it. Hydraulic elevators are somewhat uncommon. Generally, they are capped at about 5 floors because if anyone knows hydrodynamics, if you have a 1,000-foot tall piston with fluid in it, you are going to have some insane pressures at the bottom of it. So hydraulics, you will often see them in smaller buildings. You will never see them in big buildings. Anything 5 floors and over, for the most part, is going to always be cable. There's a few rare exceptions, but generally speaking, it's cable in any big buildings. And this is an example of the top of a cable or traction elevator. So you can see a bunch of cables attached in the middle. There's our car top control box. This one has a nice guardrail to make it a little harder for you to fall off of it. A lot of them do not. So this is the car top controller. This is an older model. You can see we have a few simple things here. We got power, we got a light. We can move the elevator up and down here if we're a professional. Another newer one, as you can see, they don't really change in terms of actual function. And then here, this is one of the newest models. So they're making it a little brighter, but again, the buttons, the switches, it doesn't really change. So we've gone through how a bunch of different modes work. We've gone through how the elevators function. So let's talk about how is this useful to us? Where can we actually bring this into a pen test potentially? So we're going to go through 3 different case studies. We're going to talk about a parking garage lockout. You may be familiar with that. Hall call lockout and social engineering. And none of these involve the hoistway, but these 3 are incredibly powerful. I've used these on quite a few engagements, and again, rules of engagement, a lot of the times, they're not going to want someone messing with anything too much, but these three, literally just social engineering, you're not using keys most of the time, you're doing hardly anything. So first off, we have parking garage elevator. So let's say you're in a parking garage. Generally, those are open to the public. You can get a spot there. And the elevators themselves are locked out. So they have RFID. They have something to keep you from taking it up into the main areas of the building, unless you are someone who is supposed to be there. So there's a few different ways that you can get there without that access. One of which is homing, as mentioned. So if you just call the elevator, hop into it, you don't present access, and you just wait. The elevator may home on one of the higher floors. Oftentimes they'll home on the ground floor. Parking is below that, so you can often be brought up to the lobby. Another one is waiting in the cab for a hall call. So this one works way too often, is hop into the elevator and someone at a higher floor, if you're going especially during working hours, is going to call the elevator at some point. Usually they don't have dedicated elevators just serving parking garage to ground, although that does happen sometimes. But if they have one that's doing the full height of the building, there's a very good chance someone, say on the 30th floor, calls it, you're sitting in there waiting in the parking garage, you get brought up to that floor. Finally, we have jumpering, as AA covered. You can jumper some key switches, put it into independent service mode, and that will get you out of there a lot of time. So the second one, case study 2, is hall call lockout. So you'll often see RFID readers on elevators. You look at the RFID reader, you think, that's not something that I'm prepared to deal with right now, especially with some of the newer ones. A flipper is not going to cut it. So very frequently, I would say the majority of the time, you will also notice if you start looking around the frame of the elevator or elsewhere, there will be a little key like that sometimes, or alternative ones, but either way, you'll often be able to bypass whatever very, very fancy different fob technologies they have, again, just using regular key switches. And so the final one we have is a case study. So for social engineering case study, there are a lot of ways to go about this. I would say that this is probably, I'm sure some of you have even done this, and this is definitely probably the place that you might start with elevator hacking. So first off, we have piggybacking. I'm sure that you're familiar with this in condos, for example. You don't have a key, you're visiting your friend, you walk in, someone who lives there walks in at the same time, and you just follow behind them. The same can be said for elevators. And oftentimes, what you can do with this is phone calling a friend. So let's say you get in the elevator with someone, they press their floor, you don't have a fob, so you can't press a floor, and you just silently, you just sit there, you're just staring at each other. They may be a little sussed out by that. They may think, this could be a security incident. Maybe this person's not supposed to be here. So you want to set up precisely why you are there. And this works wonders is you're on the phone with someone. You're not actually on the phone with someone, but you have your phone up to your ear. You're in the elevator. You're saying, look, man, I'm sorry I'm late. Can you please set up? I know the meeting's in 5 minutes. I'm on my way up. I forgot my fob. I'm in the car with someone. They're going up to 30th. I'm going to take the last few stairs up the staircase. They probably think you're in a rush. They probably think that you need to be somewhere. And they also probably don't assume that you don't have a fob that you're supposed to have to get up there. And carrying something heavy. So let's say someone's in the elevator. You're like, wait. You drag in something heavy. You're like, hey, can you get floor 13, something like that? That works wonders as well. And finally, concierge. So a lot of the times on newer buildings, the concierge will have a terminal tied in directly with the elevator controller. If someone comes as a guest, they'll check, they'll say, hey, okay, you're supposed to be here, and allow access to a certain floor. Well, they're a person, people can be socially engineered, so you can pretend you're a contractor, you can pretend that you have some sort of event there, but a lot of the times that's a very easy way to have the concierge themselves grant you access to whichever floor you need. So, takeaways from today's talk. This is not meant as a how-to necessarily. We are not saying you guys are ready to go out and do these things. This is more of a come along, see what it's like, see if you're interested. If this stuff does pique your interest, there are some great talks that are already out there on this content in more detail. And there are a lot of different things that you can learn that would prepare you to actually perform this in the field. So basically, the things that we want you to know about this is, first off, elevators can often present a huge overlooked vulnerability. So a lot of people will think purely in the horizontal planar of one floor for their security. They'll think, okay, you can't get through this door to this door, or you can't get to our stairwell. But elevators, in a lot of the ways that we've shown today, can be used as a direct cheat to just get right to a different floor without even thinking about any locks that may exist. There's a small set of common keys, and those don't usually matter because even if you don't have them, you can jump her in. And finally, do not go into the hoistway unless you know what you're doing. I know we've said it a few times, but it bears saying again. And so we're hoping that another thing people can take away from this is just for facilities, if you have elevators, do consider the security implications that they can have upon your facility. This is, I think, enough of a primer that you may be able to look at the call panel within the car. And if you notice any of these keys here, if you notice tubular ones especially, those are usually going to be common ones. If your facility does need a higher level of security than that, you can consider swapping those out, putting security fasteners on the panel, stuff like that. But yeah, so I think that reaches the end of our talk. So because this is recorded, we are not going to be doing a Q&A session at the front here, but we will be hanging around until 11. If you guys have any questions, you can talk with us here. If you don't think of them right now, but think of questions later, you can find us at the Village, or feel free to send us an email at any point. But thank you very much for coming.